Okay, I've got another calculator question here, and this is clearly based on the normal distribution. And if you want to read through this, attempt the question, pause the video now, and unpause it, and I'll do the solution. Okay, so we've got heights of certain plants normally distributed, and the plants are classified as the shortest 12.92% are in category A, the tallest are in category C. Now, whenever I set normal distribution or come across normal distribution questions, I always encourage my students to draw a diagram. Well, in this question, they've actually drawn the diagram for us and asked us to do things. So first of all, we've got to put this information into the diagram. So the shortest 12.92%, the shortest bit is here, and this is the shortest bit, and that's category A, and that's R, so R goes here. And this probability, because the area under here is 1, is 0.1292, 12.92%. And likewise, the tallest, so the biggest area up here, and this is the 10.38%, which is equivalent of 0.1038. And that's T, if I say in there between R and T, like that. Now actually that information is really going to help with the next part, and the next part's worth 5 marks, which seems to be a lot for basically what is only a calculator question. Given that the mean height is 6.84, so now I'm just going to jot something down, normal distribution with a mean height of 0.684 and the standard deviation is 0.25. Now that's variance, so I always square the standard deviation. I'm going to just put a line in here that represents the mean, and that mean is 0.684. Now that information is all I need. I'm just going to straight into my calculator now. I'm going to go into the stat mode, distribution, normal, and basically I've got the area and I want a value. Every time I've got the area, I use the inverse norm. I've already put in some information here for R, so let's just go through this. Using the variable, I've got the shaded left bit, that's the area I've got to the left. Here is the probability. The sigma, or the standard deviation, is 0.25, so I'm going to put that in as 0.25, and the mean is 6.84. And that's it. If I press the execute, I will get the R value. It should be less than 6.84, and it is. So R is 6.56. Now I'm going to do the same thing, exit, I come back to that same screen, but this time I'm looking to the right, 0.1038, same standard deviation, same mean, it should be bigger than 6.84, and T is 7.16, and that's it. It's a very easy 5 marks if we just use the calculator. There is another way to do it, and that is to work out put 0 here and work out the Z values, but actually for this question there's no need to do that.